Hi students, in this video we are going to solve problems related to integral powers of iota that we learnt in the previous video. Now I read the question. Find the value of minus into square root of minus 1 whole power 4n minus 3 where n belongs to natural number. Now we need to find the value of this expression. We know that square root of minus 1 is equal to I, otherwise instead of minus 1 in this place we can substitute I square, and then I square and the square root will get cancelled. We will get minus I to the power of 4n minus 3, and it can be written as minus I to the power of 4n into minus I to the power of minus 3 using exponential formula that we learnt in 8th standard. Now I write it. I'll just show you the solution. You just look at it. In this place of minus 1 I substituted I square, and then this power value as it is, this minus sign as it is. Now I remove the square root and then this square, we get minus I to the power of 4n minus 3, and it is split into two different form, product form. You just look at minus I to the power of 4n into minus I to the power of minus I. We know that 4 into n can be written as minus I to the power of 4 to the power of n. This minus 1, when we raise it to the power of 4, it becomes plus 1, and then I power 4 is, we know it is plus 1, and then this n as it is. This minus I to the power of minus 3, we know that when we have power in negative form it has to be made into positive. That's why we brought it down to the denominator. And then what we need to do is, as you know very well, here we will try to bring I power 4, that is plus 1. In order to do it, I am just multiplying numerator and denominator by minus I, so that minus into minus becomes plus, and then I power 3 into I power 1 becomes I power 4, and in the numerator we have minus I. We know that I power 4 is plus 1. Hence the answer is minus I. I hope you understand this problem clearly. Now we move on to next question. Now we need to find out the value of square root of minus 3 to the power of 23. Now what we can do is, this minus 3 can be written as minus 1 into 3. In place of minus 1 we can substitute I square, and then that I square can be brought outside the square root. We are going to use that technique. So minus 3 has been written as minus 1 into 3, and in place of minus 1 we substituted I square. That I square has been brought outside the square root with this power 23, and then we have square root of 3 to the power of 23. We know how to calculate iota power 23. What we will do is, we will divide this 23 by 4 so that we will write it in the division algorithm format, and then it can be written like this. I power 23 can be written as 20 plus 3, that is 4 into 5 plus 3. We know I power 4 is 1, 1 power 5 is 1, and then I cube value can be substituted as minus I, and then the square root of 3 to the power of 23 can be written as 3 to the power of 23 by 2. We know that I cube value is minus 3, and then this 3 value 3 power 23 by 2. So value of this expression is this. I hope you understand this problem as well. Now we move on to next concept, Cartesian form of complex number. Whenever we discuss about Cartesian form of some mathematical concept, we are talking about x-axis, y-axis, because this plane is considered as Cartesian plane. So Cartesian form of complex numbers. A complex number is an expression of the form x plus iy, where x comma y belongs to real number. If you observe it, the first part belongs to x-axis, iota times of y belongs to y-axis value. So complex number can be written in the form of x plus iy, where x comma y is belongs to r. For example, a complex number can be denoted as z. It can be expressed in this form as 5 plus 6i. I hope you can understand this. And since x comma y belongs to real number, we can also write z is equal to 0 plus like 6i. Here this value is 0, and we can write another value 0. Z is equal to 5 plus 0i, because x and y can take any real number. That's why I have written it in a different form. Such an expression is called Cartesian form of a complex number. If the complex number is written in the form of x plus iy, where x and y are real numbers, then the form of the complex number is known as Cartesian form of complex number. Based on this information, we can say that this x is called as real part of complex number, y is called as imaginary part because it is associated with I, hence it is called as imaginary part of z. Based on this information, we can say x-axis is the real number axis and y-axis is the imaginary part of real number, right? And the set of all complex numbers is normally denoted as C. We know that set of all real numbers are denoted as R, set of all natural numbers are denoted as capital N. Similarly, set of all complex number is denoted as C. Hence, the set of all complex number C can be written as in the set language set builder form as x plus iy, where x comma y belongs to real number. Since every x belongs to real number, we can say that a is equal to a plus 5y. For example, you will understand this concept with an example. We can write a natural number 5, otherwise a real number 5 as 5 plus 0i, because in 5 we do not have imaginary part, so we can say 0 into I. Hence, any natural number, any integer, any rational number, irrational number can be written in the form of Cartesian form of complex number by adding 0i. From this we can say that all real numbers are the subset of complex number. If we say 7, this 7 can be written in the form of complex number as 7 plus 0i, square root of 7. Square root of 7 can be written as 7 square root of 7 plus 0i. Hence, all real numbers can be expressed in the form of complex number. Then we can say that real number, set of all real numbers is a subset of complex number. That is what is written here. You just observe it. The set of all real numbers is a subset of all complex number. I hope you understand this Cartesian form of complex number. Now you just observe it. If a complex number is denoted as z, which is in the form of x plus iy, then as I said already, x is the real part of z. Instead of writing real part of z, it is written in the short form as rez. It means that real part of z. Y, which is associated with I, imaginary number, imaginary part, it is called as imaginary part of z, and in short form it is written as IMZ. I hope you understand this concept. Now we move on to next concept, that is equality of complex number. Here we are taking two or more numbers and we are checking whether it is equal or not. If it is equal means what are the conditions it must satisfy. That is what we are learning in this topic, equality of complex numbers. Two complex numbers z1 and z2 are taken because we are equating, and they are in the form of x1 plus i1 and the second number is in the form of x2 plus i2, are said to be equal if x1 equal to x2 and y1 is equal to y2. These two numbers, complex numbers, can be called as equal only when real part of first number is equal to real part of second number, and imaginary part of first number should be equal to imaginary part of second number. Then only we can say that these two complex numbers are equal numbers. Now we are going to solve problems related to the concept we learnt now. Now the first question is, find the real and imaginary parts of following complex numbers. First one is -2 plus 7i, in which we need to find out real and imaginary part. We know that -2 is the real part of complex number. The number 7 associated with this I will be called as imaginary part of this complex number. And the next question is 5. It is a real number. We know that 5 can be written in the form of complex number as 5 plus 0i. Now we can say 5 is the real part of z and 0i will be called as imaginary part of z. When a complex number has 0 as the imaginary part means this is called purely real number. This is called purely real. because here we have only real number, no imaginary number. If you observe the next question, third question is 6i, in which we need to find out real and imaginary part. The 6i can be written as 0 plus 6i. If you observe it, real part of complex number is 0, imaginary part of complex number is plus 6. Since real part of complex number is 0, this can also be this number is called as purely imaginary. This is purely real, this is purely imaginary. When imaginary part is 0, that particular complex number is called as purely real number. Then real part is 0, the number is called purely imaginary. I hope you can understand all these concepts what we learned now. Now we move on to next question. If 4x plus iota times of 3x minus y is equal to 3 plus iota times of minus 6, where x and y are real numbers, find the values of x and y. If you observe this, the first complex number is equal to second complex number, and we need to find out x and y value. Two complex numbers are equal only when their real parts are equal and their corresponding corresponding imaginary parts are same. Hence, we can say here, if you observe it, the real part of the first complex number is 4x, real part of the second complex number is 3. So we can say 4x is equal to 3, from which we can say x is equal to 3 by 4. And imaginary part of the first complex number is 3x minus y, and imaginary part of second complex number is minus 6. And so based on this condition, we can say they are equal. Already we calculated x value, we are substituting that value here, and we are simplifying it, we are getting y value. So these are the x and y value, that is what we need to calculate. I hope you understand this problem. With this, I am completing this video. In the next video, we will see some more concepts related to it. Thank you, students. Thanks for your cooperation.